Right now, beneath roughly 2 kilometers of compressed ice in central Greenland, there are air bubbles, tiny pockets of ancient atmosphere sealed inside glacial layers like messages in bottles, each one a chemical record of exactly what the Earth's air tasted like at a specific moment in deep time. Scientists from the EPICA project, the European Project for Ice Core Research, drilled down into those layers and pulled out a continuous climate record stretching back 800,000 years. 800,000 years of planetary breathing, preserved in ice. And what those bubbles show is something that should stop you cold. About 11,700 years ago, something happened. Global temperatures climbed between 4 and 10 degrees Celsius over roughly 1,000 years, which in geological terms is essentially overnight. Ice sheets that had buried northern Europe and North America under walls of frozen water, a full 3 kilometers high, began retreating. Sea levels that had sat roughly 120 meters lower than they are today began to rise. The climate system of the entire planet pivoted on a geological hinge point so decisive that scientists gave it a name: the Holocene, the warm epoch, the world we were born into. Here is the question that has been following me for weeks now. What if that hinge never turned? What if the orbital mechanics that drove the Milankovitch cycles, those slow, grinding shifts in the Earth's tilt and the eccentricity of its orbit around the Sun, had aligned differently, even slightly? What if the feedback loops that amplify warming had failed to cascade? What if the ice sheets had simply stayed? Not a temporary cold snap. Not a few extra centuries of glacial conditions, a permanent, locked-in ice age. The Pleistocene extending indefinitely forward, all the way through what we call the present day. What does that world look like? What happens to us in it? And I want to be precise about what we're asking, because this is where it gets strange. The last glacial maximum, the peak of the most recent ice age, roughly 26,000 years ago, wasn't just cold. It was a fundamentally different planet. The Laurentide ice sheet, which sat over North America, covered roughly 13 million square kilometers at its greatest extent. That's larger than the entire continent of Antarctica today, blanketing everything from what is now the Canadian Arctic down to the Ohio River Valley. The Fenno-Scandinavian ice sheet buried the British Isles, Scandinavia, and much of northern Germany and Russia. Sea levels were so low that Britain was physically attached to mainland Europe. Alaska and Siberia shared a land bridge, Beringia, that was not a narrow strip of ground but a subcontinent in its own right, roughly the size of modern Australia. Think about that. A landmass the size of Australia, above water and habitable, that now sits beneath the Bering Sea. That's the baseline. That's what we're asking to preserve indefinitely. And the first implication, the one that tends to hit people hardest, is what happens to geography? Not just climate, actual geography. The physical map of the planet looks radically, permanently different. Research published in the journal Quaternary Science Reviews by geomorphologist Peter Clark and colleagues built detailed models of glacial period sea levels across different climate scenarios. At sustained glacial maximum conditions, the sea level depression of 120 meters doesn't just reveal Beringia. It joins Sri Lanka to India, connects the Indonesian archipelago into a vast peninsula called Sundaland that extends nearly to Australia, exposes massive continental shelf areas off the coasts of China, West Africa, and what is now the Gulf of Mexico. The Gulf of Mexico, by the way, would be dramatically shallower and partially exposed. Florida would be roughly twice its current size. The British Isles would be a peninsula of Europe. The North Sea, where incidentally mammoth bones and Mesolithic tools are regularly dredged up by North Sea fishing trawlers because it was genuine inhabited land during the Ice Age. The North Sea would simply not exist. Here's the thing. This isn't speculation about what an Ice Age world might look like in theory. We have direct evidence of it, because humans were alive during the last glacial maximum. And we know from archaeological records spanning sites from South Africa to southwestern France to the Levant that Homo sapiens didn't just survive the Ice Age, we navigated it. We crossed Beringia and colonized the Americas. We painted the caves at Lascaux and Altamira and Chauvet, producing artwork so technically sophisticated that when Picasso saw the Altamira paintings in 1902, he reportedly said, "After Altamira, all is decadence." He meant it seriously. These were not primitive scribblings. They were the work of artists operating with full cognitive modernity under Ice Age conditions roughly 17,000 years ago. So in our alternate timeline, the world of 11,700 years ago doesn't warm. The ice holds. And humanity, which has already demonstrated breathtaking cognitive and social capacity, finds itself permanently embedded in a world that is colder, drier, windier, and geographically transformed. What happens next? The first and most fundamental consequence concerns agriculture. And this is where the research genuinely shakes you, because the emergence of agriculture wasn't just a clever idea that humans finally got around to trying. Demographic modeling, published in PNAS by archaeologist Dorian Fuller and colleagues, along with paleoclimate research from the Barr-Matthews Group working with speleothem records from Israeli caves, converges on a striking finding. Agriculture appears to have emerged independently in at least 11 different regions of the world: the Fertile Crescent, China, New Guinea, the Andes, Mesoamerica, West Africa, and others, within a remarkably compressed time frame after the Holocene began. The warming wasn't a backdrop, it was a prerequisite. The specific temperature range, the elevated atmospheric CO2 levels, which rose from roughly 180 parts per million during the glacial maximum to around 280 parts per million in the Holocene, and the reliable seasonal precipitation patterns that characterize our warm epoch are what made cereal grains and legumes productive enough to domesticate in the first place. Wheat, barley, rice, maize, the four crops that still feed the majority of humanity today, require conditions that simply do not exist at glacial maximum. And here's what the research actually shows. In a permanently glacial world, the land area capable of supporting productive agriculture shrinks by an estimated 40 to 50%, with the remaining viable zones concentrated near the equator and in narrow temperate refugia at lower elevations. Civilization as we know it, cities, writing, trade networks, organized states, is not separable from surplus food production. No surplus food, no division of labor, no scribes, no priests, no engineers, no soldiers as a specialized class. The entire pyramid of what we call complex society rests on the foundation of the farmer producing more food than the farmer's own family can consume. In a permanent ice age, that foundation is dramatically narrower. Right. So what does human civilization actually look like under these conditions? The honest answer, and historians and paleoanthropologists are careful to acknowledge the uncertainty here, is that it doesn't simply not develop. It develops differently and almost certainly more slowly, and almost certainly concentrated in radically different geographic locations. The Fertile Crescent, which gave rise to Mesopotamian civilization in our timeline, would be cold, arid steppe under sustained glacial conditions. The Nile Valley, however, and this is the part that gets me every single time, the Nile Valley would likely be one of the most productive zones on the planet. Glacial period climate modeling from the Max Planck Institute for Meteorology shows that the intertropical convergence zone shifts southward under glacial conditions, making equatorial and near-equatorial regions of East Africa, South Asia, and South America the most climatically stable zones for human habitation. The refugia of human complexity in this alternate world would likely cluster along the East African Rift Valley, the valleys of the Indian subcontinent below the ice line, and certain coastal areas of what is now Southeast Asia, much of which, remember, is exposed continental shelfland in a low sea level world. And just to be clear about the timescale here, we're not talking about a modest delay. In our actual timeline, the roughly 11,700 years since the Holocene began produced everything from the first mud brick walls of Jericho to the Large Hadron Collider. That's the full span of recorded and archaeological civilization, roughly 600 human generations. In a permanent ice age, the specific geographic preconditions that allowed that cascade to happen simply don't exist. We're not talking about civilization arriving late. We're talking about a fundamentally different developmental trajectory with no guaranteed endpoint resembling our own. And this is where it gets strange, because the implications ripple outward into biology itself. The megafauna extinctions, the disappearance of woolly mammoths, woolly rhinoceroses, cave lions, giant ground sloths, short-faced bears, and dozens of other large mammal species, are one of the most debated questions in quaternary science. The debate, documented extensively in Paul Martin's work on the overkill hypothesis and the counter-arguments from climate change advocates like Dale Guthrie, centers on whether human hunting pressure or the Holocene warming itself drove those extinctions. In our alternate timeline, that question dissolves. In a permanent ice age, the mammoth steppe, the vast cold grassland ecosystem that stretched from Western Europe across Siberia and Barinia into North America, persists indefinitely. Woolly mammoths, which DNA evidence from ancient specimens published in Nature confirms were still genetically diverse and ecologically viable as recently as 10,000 years ago, don't go extinct. They remain. Alongside them, the giant Irish elk with its 4-meter antler span, the cave bear, the Eurasian steppe lion. Stay with me, because this is where it gets philosophically uncomfortable. In a world where these megafauna survive, the relationship between humans and large animals, which in our timeline was severed almost entirely within a geological eye blink as domestication replaced predation and wild megafauna disappeared, never undergoes the same transformation. Research on human megafauna coevolution, including work by archaeologist Gary Haynes on Clovis period North America, suggests that early humans developed extraordinarily sophisticated hunting knowledge specifically adapted to large-bodied prey. In a world where that prey doesn't vanish, where the woolly mammoth remains a permanent fixture of the landscape, human cognitive and social development may remain oriented for far longer around the challenges of high-stakes big-game hunting rather than around the sedentary, storage-based, surplus-producing logic of agriculture. Different selection pressures, different social structures, different everything. If this is already making you rethink everything you assumed about the conditions required for civilization as we know it, subscribe, because we go this deep every single week. And we're about to get to the part of this that I think is genuinely the most unsettling, because we haven't talked about what happens to technology. And specifically, we haven't talked about fire. Look, fire isn't the question. Humans have been deliberately using fire for somewhere between 400,000 and possibly 1.5 million years, depending on how you interpret the archaeological evidence from sites like Wonderwork Cave in South Africa. Fire is a solved problem long before the Ice Age timeline we're discussing. The question is, what kind of technology a permanently glacial human civilization reaches, and on what timescale, and whether any of it resembles what we have actually built. Here's the thing about the relationship between cold and innovation. The historical record in our own timeline is ambiguous. The argument that environmental stress drives innovation has genuine support. The agricultural revolutions, the industrial revolution itself beginning in cold, resource-scarce northern England rather than the warm Mediterranean. But it's never a simple causal story. What is clear from climate innovation research, including economic history work by economists like Nathan Nunn and colleagues at Harvard on the long-run effects of ecological conditions on economic development, is that the specific combination of conditions that enabled the Industrial Revolution, easily accessible surface coal deposits, navigable river systems, dense urban populations creating demand for labor-saving devices, was deeply contingent on the post-Holocene geographic and demographic reality. In a glacial world, coal deposits exist, but many of the richest seams in Britain, the Ruhr Valley and Pennsylvania, are buried under ice or in dramatically less accessible geographic positions relative to the population centers that would need them. That doesn't mean a glacial civilization never discovers energy-dense combustion. It means the timing, location, and specific form of an industrial revolution in that alternate timeline is radically unpredictable from our vantage point. What we can say with some confidence, and I want to be honest about the limits of the modeling here, is that the demographic conditions enabling industrial innovation would be dramatically different. Population size matters enormously for the rate of technological development. Economist Robin Hanson and researcher Michael Kremer have both published models showing a strong historical correlation between population size and the rate of significant innovation. In our timeline, the Holocene permitted a global population that reached roughly 1 billion by 1800, providing the human capital for the industrial and scientific revolutions that followed. In a permanent ice age, with dramatically reduced arable land and a human population that demographic modeling suggests would stabilize at somewhere between 1 and 10% of our current numbers, potentially fewer than 100 million people globally, the rate of innovation is slower by an order of magnitude. Not impossible, slower, and concentrated in the warm refugia civilizations near the equator, not in the frozen north. And here is the cumulative weight of everything we've been building toward, because this is where the present-day implications become genuinely vertiginous. The world you were born into required a very specific chain of events. It required the Holocene warming. It required agriculture emerging independently across a dozen regions within a few thousand years of each other. It required the specific geographic concentration of early urban civilizations in the Fertile Crescent, the Nile Valley, the Indus, and the Yellow River valleys. It required the Roman Empire and the Islamic Golden Age, and the European Renaissance, and the Scientific Revolution and the Industrial Revolution, each one building on an accumulated surplus of food, population, and knowledge that only became possible because the ice retreated 11,500 years ago. Documented. Not one of those developments is separable from the Holocene. In a permanent ice age, the North American continent remains mostly uninhabitable north of roughly the 40th parallel, meaning everything from New York to Seattle to Chicago sits under a kilometer or more of ice. The British Isles are either glaciated or tundra. The European heartland that produced the Renaissance, the Enlightenment, the Industrial Revolution, gone. Not diminished. Gone. These are not places humans are living in large numbers in a glacial world, because the ice sheets make them uninhabitable. The civilizations that do develop, and remember, I'm not saying humanity fails. I'm saying humanity develops along completely different lines in completely different locations. Those civilizations are building in the Rift Valley, in the foothills of the Himalayas below the ice line, in the exposed continental shelves of Southeast Asia, in the Amazon basin, in equatorial West Africa. The entire human project looks different, sounds different, has different foundational myths and different founding technologies and different first cities. And this is the part that genuinely unsettles me every time I think about it. You, specifically, the person watching this video, you are the product of an unbroken chain of ancestors who survived and reproduced under post-Holocene conditions. Your ancestors were farmers, or the children of farmers, or lived in societies that depended on farmers. They lived in cities or near cities that only exist because of post-glacial geography. They were shaped by religions and philosophies and political systems that emerged from specific cultural contexts that are entirely contingent on the warm world we actually inhabit. In a permanent ice age, that chain doesn't just look different. It doesn't exist at all. You don't exist. Not as a modification or a variant. As a specific human being, product of a specific history, with specific thoughts shaped by specific cultural inheritances. Gone, not replaced by someone worse or better. Just not. That's the floor dropping out. That's what the ice cores from Greenland are actually telling us if we're willing to follow the implications all the way down. Every single thing we have ever made, every city, every book, every piece of music, Every scientific discovery, every war, every act of love and cruelty and creation, all of it sits on top of a geological event 11,700 years ago, when the orbital mathematics of the solar system, the feedback loops of the carbon cycle, and the reflectivity of melting ice sheets converged in exactly the right configuration to end an ice age. And they didn't have to. The models showed that the orbital parameters of the Holocene transition were genuinely unusual. Researchers, including André Berger at the Université Catholique de Louvain, have published work suggesting that without anthropogenic greenhouse gases, the Earth would likely have remained in a stable, warm interglacial for an unusually long period, but that the transition itself was contingent on feedback amplifications that were not, in a strict physical sense, predetermined. There were plausible scenarios in which the warm feedback failed to cascade, in which the ice held. It didn't. And here we are, talking about it, in the warm world, the only world we have ever known, built on contingency all the way down. Before we close this out, drop a comment and tell me which part of this changed how you think about the conditions that actually produce the civilization we inhabit. Was it the geography, the agriculture, the megafauna, or was it the final implication? The one about what the ice cores are really telling us about the world we were born into and how narrowly it was always going to exist? The ice bubbles don't lie. And once you've read what's inside them, the world outside your window never looks quite the same.